Okay, another video that I wanted to record here for you guys to have a better understanding of was some of the how to draw these UML diagrams for some of the stuff we've been talking about, especially as we've been now introduced to abstract classes, and next week when we move on into interfaces as well. That I feel is important that you understand how to draw UML diagrams. Now, I'm going to draw it using this sketching tool, and there are also drawing utilities such as draw.io, or I think they've now changed their name to diagrams.net. Nice thing about that one, I'll link that on the Google Classroom. But nice thing about that one is it can link to your Google account and save the files as files in your Google Drive. So that's a pretty nice feature there. But the main thing that I wanted us to be able to talk about was so the example that we went over in class where we were talking about this when we were talking about the testing, right, was the university that has courses and has students. Okay, we're going to expand a little bit on that, but because now we have that whole abstract classes thing. So now let's say that we had a class, a university, right? A university class, okay? And in the example in the test cases, what I did was I had, I had a course class, and then I also had a student class. Okay, and if you remember correctly, or if you go and look it up now, what you'll see is that the university had an array list for courses and had an array list for students. Now, what that means is that there's a relationship between university and course, and there's a relationship between university and students. We would not see courses and students listed as a set of attributes in here in the attribute section on university. No, what we would see, the way that would be represented would be as a relationship that would show that university has courses. And the way we could draw that is we would refer to that as a one-to-many relationship. Okay, and what that means is that if a course exists, it belongs to a university. If one and only one university, and the university can have many courses, 0 or many courses. Okay, same thing with the student array list. We also represented it the same way. Okay, now one thing that I want to add to this, now one thing we didn't do in the test cases example, because that was from the previous set of lecture slides, was what if we only want specific types of students? What if we want all students in our university to have some things in common, like they may all have a name, a student ID, some other things as well, right? But we don't want anybody to just be a student. They all have to be a specific type of student. Let's see. We may call it an undergraduate. That's what many of you are, right? So I think this in Turkish would be the lisans öğrenci, right? Okay, or you might have a master's student, right? Or you might have a doctoral student, right? And I think that's what yüksek, master is yüksek lisans and doctor is doctora, right? Okay, so what we could do is we could say all of these are types of students, okay? And what we could do is we could make a little notation here abstract. Okay, and and what that would be telling me is that the university has an array list of students, and students have to be one of these concrete types: undergraduate, master, or doctorate. Okay, and we could still keep everything the same about the way that the array list is defined. We could have the array list be defined as an array list of student objects, right? But the things that actually go into that array list would have to be one of these other types. So what would happen is, because student is abstract, we could never have something like student S equals new student, right? This would never be allowed, okay? Because student is now defined as abstract, okay? One other thing that I want you to be able to see, so we'll undo that because you cannot do that, so I don't want to leave that on there, and you think that that's something we can do. All right. Now, what we would then be able to do is we'd be able to say, hey, students can take courses, right? Now, students taking courses is a different type of relationship, right? A student taking a course is not a one-to-many relationship. So it's a different type of relationship. It's what we would call a many-to-many relationship, and this is the way we would note it there. What that means is that a student can take many courses, but a course can also have many students in it. All right. Now, the way that this would get represented in Java code could be different depending on how we do it. So we may have an array list of courses in student that tells me which courses a student is taking. We may have an array list of students that are in the course class that tells me which students are in a specific course. There's all kinds of ways that we could do it, right? If we wanted to be able to reference them both ways, we could put an array list of students in the course class to tell me what students are in a course, and we could do the other side too. We could also have an array list of courses in the student class to tell me which courses a student is taking. One difficulty there would be that you'd have to make sure that your data was maintained correctly, that you didn't have a student taking a course that the course didn't also have that student in it, right? Because then that would be a problem, right? And then next year, when you take my databases class, you'll understand ways that we can do this with a database that make all these things much easier to maintain than just keeping them as array lists in a Java class or something. Okay, so I want to make sure you understand all of this here, and what I'll do is I'm going to do a new diagram because I want to show a couple of examples here. Okay, so we'll do a new diagram. Okay, and maybe change the color too. So there's a couple of different types of relationships. There's a one-to-one relationship, and always what that means is we're going to have this, right? One on this side, one on this side. And what that means is for every A, there is a B. For every B, there is an A. Now, there can be all these what we call participation constraints, where an A has a B has an A, okay? And if it's required, then they'll each have to have one that points to the other. All right, but generally what will happen is you'll see one as the owner class and one as the owned class. And what that means is one will have, it'll be that one has this thing. So, for example, you might have a customer, right? Let's say we have it's a Turkcell or something like that, and a customer has a phone number or a phone, maybe just a phone. Let's just call it a phone, right? Okay, and so a customer has a phone, and it kind of goes one direction, Okay, whereas you wouldn't necessarily say that a phone has a customer. You would say it the other way around. Okay, so that would be an example of a one-to-one relationship. Then we'll have generally what's called a one-to-many relationship. The university has many courses. The university has many students. That's an example. But many could also be a specific number as well. So for an example, you might have a car and tires. And I used this example in class once as well, where you might say, okay, a car has 4 tires. Okay. And so this would be, again, a type of ownership relationship. One-to-one relationships are harder to see the ownership sometimes, whereas because we don't really have this in real life a whole lot. Because even like the customer phone example isn't a perfect example because a lot of customers have more than one phone for a Turkcell, or at least the possibility to have more than one phone. Okay. But like a car having 4 tires is pretty easy to see. Okay, a car has 4 tires. Like that's the you have the owner over here, the owner of, and the owned things. Right. This has something, so it goes this direction. The car has the tires. Okay, and then finally we have the many to many relationship. The example that we just saw was a moment ago was the students taking courses. Another example where you might have a number on one side is you might have a parent and a child. Right? And you might see that a parent can have many children, right? As many as they want, right? But a child will be coming from 2 parents, right? And so you'll have a child will come from 2 people, right? And this is actually an interesting example because both of them, we could have a person class, right? Right, a person class that both parents and children are types of people. Yes, your parents are actually people, and your children will be people as well. But the main point I'm trying to make here is that this is a different type of relationship, right? So remember, these that I've described over here, these are types of has a relationships. So a customer has a phone, a car has tires, a parent has a child, right? Whereas this one here, this relationship here, let me draw that in a different color. Let me note that with a brighter, like a red color here, right? A parent is a person, a child is a person. This is a type of is a relationship. So make sure you know what the appropriate diagram representation is. Again, is a relationships one-to-one, right? So a parent is a person, right? This parent extends, right? And the key word here is extends, right? A child is a person. Right, it cannot extend from any other class, right? Whereas these has a relationships, right? These has a relationships can have different numbers on each side. Okay, so the way that is a relationship gets implemented is using the extends keyword to tell me that this class inherits from another class. The has a relationship, the way that gets represented in Java is we may have an array list, all right, where a parent has an array list of child objects. A car might have an array or an array list of tire objects. We'll get to other data structures later. A customer will have a variable for their phone object, right? So these are all ways that can get done. So the has a relationship, we put a variable or an array list of variables in there, or objects in there. For the the inheritance relationship, we use the extends keyword. Okay, I hope this clears things up. If you have questions, please contact me or one of the teaching assistants, and we'll be glad to maybe help explain this a little bit further if you're still confused.